In the previous video, we talked about our perfect squares and perfect cubes. So in this video, we're going to look at how perfect squares and perfect cubes relate to finding the area of a square and finding the volume of a cube. Also, we're going to look at estimating square roots, and we're going to estimate cube roots, and then we're going to solve a couple of equations that have a squared, a number squared, a variable squared, and a variable cubed. Okay, so let's go back to this first page here. And let's start. So when we're talking about finding the area of a square, we know that a square is a four-sided polygon. It is flat shape. It's not three-dimensional, it's two-dimensional. And we know that all four sides have the same length. That's the key here, and that's why we can use perfect squares. So it says, given one side length of a square, we can square the side length to find the area. So if our example is we have a square that has a side length of 8 centimeters. So our example up here tells us to square the side length, and that'll give us the area, because area we know is length times width. Well, in a square, the length is the width, so they're the same. So 8 squared gives us 64. And then we look at our label. So that'd be 64 centimeters squared, or 64 square centimeters. Now this works backwards. You know, if they give us the area, we can find the side length. We just take the opposite of squaring a number, which is the square root. Okay, so we take the square root of an area to find the side length. So our example here says that the area of the square is 144 square inches. So we take the square root of 144, and that gives us 12. So we get 12 inches for our side length. Notice that my inches is not squared because this is a side length. My centimeters was cubed up here because this is my area. Okay, so now let's look how this works with cubes. All right, so now it says, given one side length of a cube, we can cube the side length to find the volume. Okay, so we have our side length of 3, and we're trying to find the volume. So a volume of a cube is a three-dimensional shape. That's why we can find the volume. It has a length, it has a width, and it has height, so it can hold things. And it's made up of squares, so all the side lengths are the same. That's why we can just cube this number. So 3 cubed, and that's going to give us 27 cubic centimeters. All right, just like the square root, it works backwards. We can take the cube root of the volume to find one of the side, or to find all of the side lengths. So this tells us our volume is 343 cubic millimeters. So we take the cube root of that, so that gives us 7 millimeters, cube root. Okay. Now let's look at how to estimate square roots and cube roots. When we're estimating square roots and cube roots, the strategy that we like to use is to make a number line, and then we put on the ends of our number line the two perfect squares that the square root of 200 falls between. So let's start like this. So we make our number line, and we're trying to find the square root of 200. So we're going to think of the two perfect squares that the square root of 200 would fall between, and that's going to be 14 and 15. So I'm going to put 14 here, and I'm going to put 15 here. Okay, so now 14 squared, from the previous video, we know that is 196. 15 squared, 225. So that's what I meant by the square root of 200 falling between 14 and 15 squared, right? 200 would be somewhere in between here. It's not going to be exactly in the middle, but it's somewhere between 14 and 15. So our goal here for estimating is we want our answer to be between 0.23, so 23 hundredths of accuracy. Okay, we're estimating. We're finding the closest possible value without having to sit here and do this forever. So we're going to do this twice, and we're going to show you how we can get as close to possible for our answer. Okay, so now we're looking here, all right, what's between 14 and 15? Well, we can say 14.5 or 14 and a half. So really, how did I do that? I averaged together 14 and 15. So I do 14 plus 15 to get 29, divide that by 2, and that gives me 14 and a half. So to find this number, I'm going to do the same thing. So I'm going to add 225 and 196. Okay, so I add that, and I get 421. So now what I do is I take 421, and I divide it by 2. And I'm going to get 210.5. Now, since we're estimating, we can just leave off that 0.5, and let's just say this is 210 approximately. Okay, so now what we're going to do is we've separated it into two sections. Okay, so now is the square root of 200 going to be between 196 and 210, or 210 and 225? It's going to be here, because 200 falls somewhere between 196 and 210. So I can forget about this side of my number line. So I'm going to do this one more time. What's between 14 and 14.5? 14.25, right? Okay. So now I'm going to do that again, but I'm going to use the numbers 210 and 196. Okay, so I'm going to do that right here. So I go 210 and 196, and I'm going to add those together, and I get 406. Okay, so I'm going to do 406 divided by 2, and I get 203. So I can say that this is approximately 203. Okay, so now I'm going to evaluate again. Would 200 be here or here? Right, it's going to be between 196 and 203. So I can say that my answer, I know it's not 14, I know it's not 14.25. So it's got to be between 14.01 and 14.24. Somewhere in this range is my answer. Okay, so now from here I can just guess anywhere between 14.01 and 14.24. All right, so I'm going to go with 14.14, and that's my answer. So once again, I could have said 14.02, 14.10. All those would be estimating of that square root. Okay, so now let's do the same thing, but with a cube root. Okay, so for a cube root, we're going to make the same number line, but we are going to think about our cube roots instead of our square roots. So number line. All right, so the cube root is 75. So the cube root of 75 is going to be between 4 and 5. Okay, so now what's 4 cubed? Right, 64. 5 cubed, 125. All right, so 75 is between 64 and 125. So now once again, we're going to follow that same strategy. This would be 4.5. So I'm going to take these two numbers, 64 and 125, I'm going to add them together. 64 and 125. I'm going to get 189. And then I take 189 and I divide that by 2. And I'm going to get 94.5. But once again, just like our square root example, just forget about that 0.5 because we're estimating. So we'll go 94 right there. Okay, so now are we looking between 64 and 94 or 94 and 125? Right, we're not looking here anymore. We're going to be over here. Okay, so now we're going to 4.25. And we're going to do the same thing here. We're going to take 94 and 64. And we're going to add those together and we get 158. And then we're going to divide that by 2. So 158 divided by 2, and we get 79. Okay, so we can plug 79 right there. Okay, so now we know that we're looking between 64 and 79. So we're right here somewhere in this range. So we could say 4.01 between 4.24. Somewhere in that range would be a good estimation of our answer. All right, and we can think about this. I didn't mention this on the square root, but if we're looking at 75, is 75 closer to 79 or 64? Right, it's closer to 79, so our answer is going to be closer to 4.25. If we look at that up here, we had 200. So is 200 closer to 203 or 196? It's closer to 203, barely, just by one number, right? It's only 4 away from 196, and it's 3 away from 200, okay? So we could see that our answer is going to be closer, slightly closer to 14.25. So back down here, all right, we had 75. So we can pretty sure say that this is closer to 79. So let's go with 4.22, and that's our answer. Okay. The last thing we're going to look at is how to solve a couple equations that have square roots and cube roots in them. Okay, so let's look at our first equation. All right, it says 6x squared minus 9 equals 1,527. Okay, so the first thing I'm going to do, just like a normal equation, I'm going to add 9 to both sides. So that 9 is canceled. So now I'm left with 6x squared equals 1,536. All right, so now this is 6 times x squared. So to undo the multiplication, I'm going to divide by 6 on both sides. So that cancels that 6 right there. And I'm left with x squared equals, and then I do 1,536 divided by 6, and that gives me 256. So now this says what number squared equals 256? Well, to undo the squaring of that number, I take the square root. So I do that to both sides. And I know that the square root of 256 is 16. Okay. Now we have to actually be careful here because there's actually two answers, positive 16 and negative 16, because we know that 16 times 16 is 256, but also negative 16 times negative 16 would give us a positive 256. So this is kind of how we write that right here. We say x is equal to plus minus 16, or positive and negative 16. That works if we're taking the square root of a number. Okay, the last one we're going to look at is an example that has a number that is cubed. Okay, so actually we have parentheses here, so the first thing we're going to do is follow the distributive property. Okay, so I'll draw my lines here. So I'm going to distribute that 5. So I have 5x cubed minus 10 equals 3,635. Okay, so now I'm at the same spot I was in my other equation. So I'm going to add 10 to both sides. This 10 cancels. I'm left with 5x cubed equals, and I have 3,645. Okay. Now, same thing as the first equation, I'm going to divide both sides by 5. So I'm left with x cubed equals 729. So now to take the, to undo cubing that number, I take the cube root of both sides. Okay. And now I find that the cube root of 729 is 7. All right, so here it is just positive 7, since we're cubing the number, or taking the cube root. All right, it's not negative 7, because negative 7 times negative 7 times negative 7 would result with a negative 729. And we just need a positive 729.